What's up, scholars? Today we're talking about triangle congruence and the side-side-side congruence postulate. So what is the definition of congruent triangles? Well, they are triangles that have all of their parts and pieces that are the same measure. Triangles that have all their sides and, let's emphasize that, and all their angles congruent. So if I wanted to prove the two triangles are congruent, I would have to show that all of their sides are congruent and all of their angles are congruent. That would be a lot of measuring. There has to be a better way. It turns out if you just know that their three sides are congruent, then you know the angles have to be congruent and they will definitely be congruent triangles. I'm going to show you why that is the case. All right, let's go to our good friend GeoGebra Classic. Oh, there it is. That's the good stuff. We're going to make a triangle. And I'm going to show you that if we make two triangles have the same side measures, their angle measures will have to be the same. So I'm going to do this as randomly as possible here. Plot a point, and I'm going to make a circle with a certain radius. I'm going to make triangles based on circles. So just hang on here for a second. All right, I've got a triangle. I have a circle with a radius of 5. So any segment I draw from point A to the outside will have a length of 5. So let's draw a, I want a ray here. Let's just go in this general direction. And let's say I really want the point that's right on the edge of the circle. So I'm going to go grab it from an intersection between these two. And I'll know now that from point A to point C, I've got a segment that is 5 units long. Ta-da! Segment AC is 5 units long. Okay, great. Now let's make another segment of this triangle. Let's make it off of point C, and we'll make it 12 units long. So make another circle with a radius of my choosing, and I'm going to say 12 units long. Okay, cool. Whee! It's way out here. Great. And I'm going to make another circle with a radius of my choosing off of point A. This will give us our third side. It's going to be 13 units long. So now if I connect the intersection of these two outside circles, this guy and this guy, I'll have a segment that is the radius of that 12 unit long circle that we made, right? From C to E is going to be 12 units long, see right there. And from point A to point E, that's going to be 13 units long. All right, got it. So what we're looking at here is this this triangle that has vertices at A, C, and E. Got a triangle here, A, C, E. And let's measure the angles. Measure the angles. I can do that by clicking on the points. Well, that angle is 90 degrees. How about this angle E here? Boop, boop, boop. That angle is 22.62 degrees. Doop, doop, doop. And that angle is 67.38 degrees. All right, I've done nothing real here about proving that two triangles are congruent. I've just measured the sides and the angles of this one triangle. If I zoom out a little bit, I can make another triangle that will have the same sides on the other side, same side lengths. And tell you what, the angles are going to be exactly the same. So we've got the intersection over here. Let's connect point C to point D, and that will be a 12 unit long segment. And point A to point D, that'll be a 13 length segment, just like the other triangle. So we know the two sides are the same. And now let's see if the two angles are the same. Or A to C to, oh, let's go in the other direction. I kind of want it to go. We go backwards. Let's go D to C to A. All right, there we go. There's another 90 degree angle. And how about C to D Oh, I just took one the wrong way. Doesn't like me going that way. Try again. Stay inside. Stay inside your lines here, I reckon. There we go. That is 22.62 degrees. That was the same as the other side of our triangle guy. And I need this angle up here. Let's see if I can go in the right direction this time. Nope, I still went in the wrong direction. Try again. So C to A to D. That's also 67.38 degrees. So these two triangles, I made them such that they have the same side lengths and their angles are the same. This is actually a classically famous length of side triangle because it's a 90-degree angle here. So these are special, it's a right triangle with its side lengths that are whole numbers. So it's called a Pythagorean triple. But I could ask Google, what are the angle measures of a 5, 12, 13 triangle? And it's going to give me the same answers too. What are the side lengths of a 5, 12, 13 triangle? I spelled it wrong, so now it's gonna be annoyed about it. Pretty sure the side lengths. Oh, I don't want the side lengths. I want the angle measures. I want the angle measures. I know the side lengths. I want the angle measures of a 5, 12, 13 triangle. There we go. There we go. See, I knew it was happening. 22.6 degrees, 67.4 degrees, and 90 degrees. That's what we got when we measured on GeoGebra. There's no other way to make this triangle with side lengths 5, 12, and 13. And that will be true for literally every triangle you make. All of the angles will always be the same if you know the sides are the same length, which is a great relief because now if we want to show that triangles are congruent, we don't have to show that all their sides and all their angles are congruent. We've got a shortcut now. Whew, thank goodness. That's the side congruence postulate. Side. Spelling is great. Congruence postulate. Sometimes called SSS from here on out. We'll play SSS because that was a lot of typing. I would like to just say 3 letters. Thanks so much. If all three sides of a triangle are congruent, then the two triangles are, what we should say, if all 3 sides of 2 triangles, if all 3 sides of 2 triangles are congruent, then the 2 triangles are congruent. Meaning that all their angles are also congruent. And that would be all of our 6 parts. If just 3 sides of a triangle are congruent, then the angles must also be congruent. The 2 triangles themselves are congruent. All their parts, all their pieces are congruent. All right, so it's time to do example proof. Let's say we have these 2 triangles. That we are told that B is the midpoint of segment AC. And we're going to prove that triangle ABD is congruent to triangle CBD. We also know that side AB is congruent to side CD. So let's mark that here. All right, so we have 2 givens. One, that B is the midpoint of segment AC, and also that segment AD is congruent to segment CD. We're going to use this information to prove that triangle ABD is congruent to triangle CBD. In a, you guessed it, statements and reasons type fashion. Statements and reasons. Everything we say will have some sort of reason to go with it. Let's underline that sucker. Great. And you know what? I think we could, let's move my head over here. Let's do that. Let's give ourselves some more space, maybe, for typing these statements and these reasons. Okay, fabulous. Here we go. So we're going to make arguments to show why these 2 triangles are congruent. Let's start an argument with what we are given. We are given that AD is congruent to CD. All right, AD is congruent to CD. Again, the reason that's true is because it's given. Okay, great. We're also given some more information that B is the midpoint of a segment AC. B is the midpoint of segment AC. That's also true because it is given. All right, so how do we use that second one, that B is the midpoint of AC? Well, B is right in the center. That means these two parts, AB and BC, must be congruent to each other. That's what a midpoint does. It splits segments into two congruent parts. So we can say AB is congruent to BC because that's what a midpoint does. The definition of a midpoint is to split a segment into two congruent parts. So segment AB is going to be congruent to segment BC because of the definition of a midpoint. So one more time, segment AB is congruent to segment BC because that's what a midpoint's job is to split a segment into two congruent parts. That's the definition of a midpoint. All right, so we have two sides that are congruent. If we can figure out why the third side of these triangles are congruent, then we'd be in business because we know all three sides are congruent. And if we know all three sides are congruent, then the triangles have to be congruent because we showed that previously in our side congruence postulate, little graphical proof here. What is the third side of these triangles? Well, we've got triangle ABD and triangle CBD. They share the side BD. Well, if they share it, it has to be the same on both sides, right? Because it's shared. It's literally the same thing. So it's true that the three sides of the triangle are congruent because BD is congruent to itself. It has to be. It's itself. Side BD is congruent to itself. So when something is congruent to itself, the reason it's congruent to itself is called the reflexive property. So we use two big things just right here. We talked about the definition of a midpoint. A midpoint's job is to split a segment into two congruent parts, so it makes congruent segments. And the reflexive property that something is congruent to itself. And a shared side here would be something that's congruent to itself. Both of these triangles have the same side, BD, and must be congruent to itself. So we now have all three sides of these two triangles are congruent to each other. So those two triangles must be congruent to each other by side, side, side. Okay, let's review what we just talked about. We said the things we started out our argument with were our givens, that side AD and side CD were congruent to each other, and that B was the midpoint. And then from that midpoint, we could say that side AB was congruent to side BC, because that's what a midpoint does, that's its definition. And their shared side, BD, is congruent to itself by the reflexive property. So then we have one pair, two pairs, three pairs of congruent sides in these two triangles that are congruent. So the triangles are congruent by side, side, side congruence postulate. All right, so let's recap. We did a graphical proof of two triangles having the same side lengths, have all their angles the same. So we are proving why the side, side, side congruence postulate is true. And then we talked about our example proof, which used the definition of midpoint and the reflexive property to show, again, that if all three pairs of sides are congruent in a triangle, in two triangles, then those two triangles are congruent to each other. All right, that's it, scholars. Love you so much. Keep on that hustle. Peace.